Any questions on the homework before we get started? Because I know we only had one assignment so far, but questions? Okay. So we started working on this one here, and we ended up stopping because we got to the point that we had 3x times 1 minus x over x plus 5 times x minus 1 in the first one. Our second one, we had x plus 5 times x minus 4 over 3x. So we finished factoring all the way through. We got to this point, yes? Then we multiplied them together, and on top we had 3x times 1 minus x times x plus 5 times x minus 4, and on bottom we had 3x times x plus 5 times x minus 1. And this is where we stopped because we ran out of time yesterday. Because once we finish factoring these, to do multiplication, we factor the tops and bottoms of each fraction, then we multiply them together, and then we're going to simplify. We're going to cross out what's in common on top and bottom, what's going to simplify to 1. Now, one of the ones that we can see for sure is x plus 5 and x plus 5, because x plus 5 over x plus 5 simplifies to 1. They simplify out. What else is going to simplify out? Well, 3x over 3x. Again, we can move those out to the front or to their own fraction. 3x divided by 3x is 1. It simplifies out. Now, what that leaves us with, on top we have 1 minus x times x minus 4. And on bottom we have x minus 1. Now, something that's interesting is that the x minus 1 and 1 minus x do look very similar to each other, yes? But the only difference between the two is that the one on top, the 1 is positive and the x is negative, and the one on bottom, the x is positive and the 1 is negative, yes? So, I'm going to try something. If, in this set of parentheses here, the 1 minus x, I factor out a negative 1 from it. I factor the negative out. If I factor the negative away from negative x, it's going to become positive x. We factor it out. We divide it out, giving us positive x. Now, if I factor that negative 1 out of positive 1, it'll still be 1, but it's going to change it from positive to negative. Still have the x minus 4 multiplied by it, and we still have x minus 1 on bottom. But by factoring out that negative, it turned it from 1 minus x to x minus 1, which means that x minus 1 on top and bottom are the same. Now, it seems odd that instinctually we know to do this, or this would be a rational step. But if we get two sets of parentheses that have the same terms, but the signs are all flipped, instead of it being positive, it's negative. Instead of negative, it's positive for every single term in that set of parentheses, then we can factor that negative out and do that. Which now means that x minus 1 over x minus 1 will cancel. On top, we still have the negative. We still have the x minus 4. Do we have anything left on the bottom of the fraction? No, so it's just going to reduce to 1. We're not going to write over 1. We don't have to put over 1. It's just understood. So really, the final answer is just negative x minus 4. Questions on this here? Now, not necessary for the homework, but if we looked at the restrictions, we have to look at it. We have to find them before we start reducing anything, before we start simplifying anything down. And this one here actually has 3 places that x could cause a division of 0. It could be with our 3x term, our x plus 5 term, or the x minus 1 term, because if any of these 3 expressions is 0, it's going to cause the whole denominator to be 0. Now, the easiest one out of the 3, or the nicest one out of the 3, is our 3x. Because we're saying 3 times x is 0. Well, we can divide both sides by 3. 3x divided by 3 is x. 0 divided by 3 is 0. So that's just saying x cannot be 0. With our x plus 5, again, we just set it equal to 0. Solve for x. And here we would subtract 5 from both sides, telling us that if x is equal to negative 5, it would cause a division of 0, so x cannot be negative 5. And lastly, with x minus 1, we would add 1, telling us if x is equal to positive 1, we'd have a division of 0. X cannot be 1. Yes, sir?
On the test, will it ask us to where they
No. Especially with addition, subtraction, multiplication, solving. For the most solving, I will have to re-look back at it, but for the most operation simplifying, no. Questions on this here? Any other questions? We good with this here? Let's look at the next one. 5x minus 5x squared over x minus 4x plus 3 times x squared minus 5x plus 6 over 5x. So the first thing we need to do before we start multiplying is factor all 4 spots, or factor them as far as we possibly can. Out of the 4 spots, there's one that's not going to factor at all in any way, shape, or form. Which one would that be? The bottom fraction on the left, the 5x. It's a single term. There's nothing we can do with it. It's factored. Next one I would look for is greatest common factor. If there's something we can pull a greatest common factor out of, the top fraction, our 5x minus 5x squared, there is a greatest common factor between those two, yes? And it would be what? 5x, yes? Now, one thing I would make note of, because it's similar to what we did on the last one, our 3x minus 3x squared. The x squared, the bigger term is going to end up being negative, yes? Well, that caused issues last time because we want that x, that variable, the biggest one, to be positive. So what we can do is what? We can factor out a negative. Because that x squared term, that variable with the biggest exponent, is negative, if we factor that negative out, we're going to simplify, we're going to make it easier for ourselves later on. Because if we factor the negative 5x out of 5x, well, 5x factored out of 5x will factor out completely, which would be 1. But if I factor a negative out, since it was positive, it's now going to be negative. Now, when we factor 5x out of 5x squared, the 5 will factor out completely. When I factor an x out of x squared, we would have x. But because it was negative, and I factored the negative out, it's going to become what? Positive. Now, we'll flip that around once we go to the next step and before we start multiplying, because really we won't leave it as negative 1 plus x. We're going to write it as x minus 1. Questions on this here? Where do we want to go next? X squared minus 4x plus 3 or x squared minus 5x plus 6? Bottom or top? Bottom. X squared minus 4x plus 3. Again, greatest common factor is the first place to look. See if there's a common factor between x squared, 4x, and 3. And well, there's not one. 3 doesn't have a variable. X squared doesn't have a number in front of it. So there's nothing to factor out. But we will still have 2 sets of parentheses with 3 spaces because it is a quadratic. We do have that power of 2. Since the third term is positive, the signs are the same and match the sign of the middle term, which is negative, so it'll be negative and negative. Factors of x squared are x and x. That's our only choice. Factors of 3 are 1 and 3. That's our only choice, yes? And really, realistically, this is the only setup that we have, x minus 1 times x minus 3. Because even if I flip the 1 and 3, x minus 3 times x minus 1 is still the exact same expression. If I wanted to check it off to the side to make sure, x times negative 3 is negative 3x. Negative 1 times x is negative x. Negative 3x minus x, negative 3 minus 1 is indeed negative 4, which is the middle term we wanted. Okay. Let's look at the top of the other one, the last one, x squared minus 5x plus 6. Now, there is no greatest common factor between x squared, 5x, and 6. There's nothing that goes into all three. Part of the way we know is the number in front of x squared is 1, and 6 doesn't have a variable. So there's nothing we can do there. Since the third term is positive, the signs are the same and match the sign of the middle term. So we have negative and negative. Factors of x squared are x and x, the only set we have. Now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try? Two and 3. Because I would still, again, I'd be looking at the bottoms of the fractions. Because when we multiply, we're going to pretty much put all the parentheses on top together. On bottom, we're going to put all those parentheses together. And if something's going to reduce, we have to have something in common on top and bottom, yes? Well, it could be 1 and 6 because we could get that x minus 1 by plugging 1 in one of the spots. But wait. Don't we essentially already have an x minus 1? So if we do, we'd have 2 on top, one of them on bottom. Only 1 can cancel with 1. We can't cancel 2 with a single 1. So there's a better likelihood that if it is 2 and 3, our x minus 3 and x minus 3 would cancel. We have one less thing on top and bottom. Now I can check it and make sure. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. And negative 3x minus 2x, negative 3 minus 2 is the negative 5 that we wanted. Questions on how we factored any of this here? Now we need to multiply the top and bottom. So on top, we'd have the negative 5x times, I would fix that negative 1 plus x. And rewrite it as x minus 1 times x minus 2 times x minus 3. On bottom, I would move that 5x to the front, have x minus 1 times x minus 3. Questions on this here? Now we just need to factor. We need to, well, not factor, we just need to simplify what's in common on top and bottom. Now the parentheses, well, apparently I'm just going to erase that. Still erase that. The x minus 1 and x minus 1 would cancel. The x minus 3 and x minus 3 would cancel. Now we can say the 5x and 5x would also simplify. And that tells us that on top, it would indeed leave the negative. Because we're simplifying the 5x and 5x, not negative 5x. Now the negative would simplify if on bottom we also had negative 5x, or had a negative down there. So the only thing we have left is negative x minus 2, negative parentheses x minus 2, close parentheses. And we can leave it as this here. We don't have to rewrite it in any other way. I don't have to multiply the negative through and say that it's negative x plus 2. These are equivalent statements. They are the same thing, but we can just leave it as negative parentheses x minus 2, close parentheses. And since we're here, we'll go on and look at the restrictions. Well, the 3 places where x can be 0 is at 5x, x minus 1, and x minus 3. With 5x, again, we can solve this in one of two ways. The main way that most of us will go to is divide both sides by 5. 0 divided by 5 is 0, so x cannot be 0. But the other way to think of it is, well, we have two things that multiply together to get a 0. 5 times x, two things that multiply together to be 0. 5 cannot be 0, so x has to be 0. X plus 1, or x minus 1, we would add 1 to both sides. Our negative 1 plus 1 would cancel. Telling us that x is equal to 1 would cause a division of 0, so x cannot be positive 1. And lastly, with x minus 3, we would add 3 to both sides, and our negative 3 plus 3 would cancel out, telling us that if x is equal to 3, we'd have a division of 0, so x cannot be 3. Questions on this here? Okay. We're going to look at a few more products, and that's really the last pieces of 731. So we look at this one here, 2x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. Now it's figuring out where to start, especially with factoring on this here, because we still have 4 expressions. We have 4 places we're looking, yes? I would look at the second one. That's going to draw my attention first, because we have x plus 3 on top and 2x squared on bottom. Now 2x squared on bottom, we do have a degree of 2. There is possibilities, especially if it's a degree 2, there's a good chance it factors, yes? But how many terms do we have there? 1. I can't factor out a greatest common factor from one term. All I'm doing is putting parentheses around something. There is nothing we can do with it because it is a term, a single term. So 2x squared, nothing we can do with it. Next place I'm looking is right above it, x plus 3. Is there a greatest common factor between x and 3? No. So the degree is 1. That is simplified. There's nothing we can do with either one of those because they're already simplified. Nothing we can do with it. So now we're looking between 2x squared minus 10x and x squared minus 25. Which one do we want to look at first? 2x squared minus 10x. Is their greatest common factor? Yes, and? X. Since 2x squared and 10x, they both 2 and 10 have a common factor of 2. They're both divisible by 2. And since they both have an x, we can factor 2x out of both. Now when I factor 2x out of 2x squared, it's going to be x. Minus, when I factor 2 out of 10, 10 divided by 2 is 5. And the x factors out completely. Now the question is also, why would I not factor out a negative on this one? Because on the last two, we factored out a negative with our greatest common factor, yes? What's the big difference between this one and the last two? What's the sign of our variable with the biggest exponent? The x squared is positive, yes? If I go back to the preview, and what's the sign of our x squared term? Here it is. Negative, yes? Because this one, the x squared, that variable with the biggest exponent, is positive already. Factoring out a negative, if I factored a negative out of here, this x would have not been positive, it would have been negative. And the 5 would not have been negative, it would have been positive. We want that variable positive. Even if this had been a cubic squared and then we had a term with x, if that cubic is positive, we want it to stay positive. If it's negative, we want to make it positive, because we want that first term positive. Because it makes it easier to factor. Now we have one last base to factor before we move on and start doing more of this here, and that's the x squared minus 25. Is there a greatest common factor between x squared and 25? No. But it's looking like it could be a difference of perfect squares. X squared is x and x. 25 is what? 5 and 5. So x squared minus 25 would factor 2. X plus 5 times x minus 5. And now we need to multiply these two together. Now on top, we still have the 2x being multiplied by x minus 5 times x plus 3. Now, I just added those parentheses around the x plus 3, but it's understood that they are a term. So when we multiply these sets of parentheses together, especially the x minus 5 times x plus 3, we'll have to put the parentheses around it to show it's one whole term and that they're being multiplied together. Questions on how we wrote that? Because sometimes it seems like, well, the parentheses around the x plus 3 just showed up. They've always been there. We just don't write them because it's understood that they're together. There's nothing else there with it. So we don't need it. We weren't needing them up to this point. But since we're multiplying that whole term x plus 3 by x minus 5, we need the parentheses to show that that's one term. Those two terms are being multiplied together. On bottom, we're going to multiply the 2x squared. X plus 5 times x minus 5. Questions on how we got to this point here before we start simplifying? So, x minus 5, x minus 5. X plus 3 and x plus 5 won't simplify. Now, our first term up to this point, we've just crossed it all the way out, yes? Here we have what? 2x over 2x squared. So will the 2x and 2x squared simplify out completely? Well, no. The 2, yes, 2 over 2 would simplify to 1. We're fine there. X over x squared, we're dividing like bases, so we would subtract the exponents. 2 minus 1 is 1. Since it's bigger on bottom, it will stay on bottom, yes? That is one way to do that, so we know that we do have x on bottom. And we still have the x plus 5. On top, we have x plus 3. And kind of as I stated just a minute ago, we don't necessarily need the parentheses around the x plus 3 because there's nothing else with it. It just shows that they're stuck together. Now, having it is not wrong. Leaving it off is not wrong either, especially for the top. On the bottom, the parentheses around x plus 5 is needed to show that we're multiplying x by the whole expression x plus 5, not just the x. And that's our answer there. X plus 3 over x times x plus 5. You do not have to multiply it out to say that we have x plus 3 over x squared plus 5x. Not necessary. This is the answer. Multiplying the denominator does not make it more of the correct answer. It is still the exact same answer. Now, I'm going to show you this here, especially with factoring x squared over x, these single terms where they don't factor out completely. One way I do it, especially with writing it, it's a little messy, in that I will come up here because I know all the x's on top are going to cancel out completely, yes? And we're moving how many from the one on bottom? It's going to go back to 1, yes? So for me, I'll come down and mark the 2 out and change it to a 1 because that's what it's going to reduce to. That's one way to do it. If you're able to keep track of that and see that, awesome, do that. If not, don't do that because especially once we have a lot of terms, greatest common factor terms, it can get a little messy a little quick. Questions on this here? Not going to worry about it too much. But if we listed our restrictions, we would say that x is not equal to 0, x is not equal to 5, and x is not equal to -5, because those would be the three terms, phase values that would make the denominator be. We're going to do this one and two more, and then we are actually done for the lesson, or done with this lesson. This one here has multiple steps, especially with factoring. Now, the first one I would look at, because we do have some complex terms, we have only one nice, really quote-unquote nice one, and that's the c squared minus 2c plus 4. Only one that's actually quadratic. I'm going to handle the cubic first. C cubed plus 8 cubed. This is our a cubed plus b cubed. You don't necessarily have to write that. That factors 2a plus b times a squared minus ab plus b squared. Minus ab plus b squared. Now, to get there, we'd see what times itself 3 times goes in a, and that would be c. And what times itself 3 times gives us 8, which would be 2. So in the first set of parentheses, we'd have a plus b, so that'd be c plus 2. In the first spot, we have our a squared, so that'd be c, that whole term squared, minus a times b, so c times 2, plus b squared, which would be 2 squared. So we went over that. I know that's still relatively new. We've done factoring several times throughout the year, especially last semester. Cubics were new. We didn't get to them last semester. We got to them this semester. Questions on this so far? Now, something does seem pretty interesting with this here. Inside that cubic, the quadratic part of it, well, if I went on and simplified it, that'd be c squared minus 2c plus 4, yes? Well, why is that familiar? Wait a minute. That other denominator is c squared minus 2c plus 4, yes? Well, we know two things. One, I've told you several times, the quadratic part of a sum or difference of perfect cubes will never factor. That's just a given. They won't factor. So that tells us, one, that the denominator, the other denominator, c squared minus 2c plus 4, should not factor either. Even if it did, does it matter? No, because I would now have an expression on top and bottom that are the same. Even if they did factor, they should factor to the same factors, which means they will still cancel each other out. And if we see something like that where we have the same expression, there's no reason to factor it because they're going to cancel out anyways. The only reason we would do that is specifically to find restrictions. Times of x don't make the function be 0. We'll go to the one on bottom since it's right there. C to the 5th minus 4c to the 3rd. Is there a greatest common factor? There is. It is c cubed. Because if we factor c to the 3rd out of c to the 5th, we're left with c squared. And with our 4c cubed, we factor the c cubed out, we're left with 4. On top, c to the 6th minus 4c to the 5th plus 4c to the 4th. Well, we have c to the 4th. 6, 5, 4. We can factor out c to the 4th out of all 3. And if we do that, we get c squared minus 4c plus 4. Questions on how we got to this here? Doesn't matter where we go from here. I'll go with the denominator. because c squared minus 4 can factor. C squared's a perfect square. 4 is a perfect square, and they're being subtracted, which means it's a difference of perfect squares, which tells us it factors to what? C plus 2, C minus 2. Perfect square, C times C is C squared. 2 times 2 is 4. On top, we do have C to the 4th. Inside the parentheses, C squared minus 4C plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. Negative, negative. Factors of C squared, well, there's only one set, C and C. Now, our factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. Because with the 2 and 2, we would have something in common on top and bottom that would cancel out, that would reduce. And if we check to make sure we get negative 4c, c times negative 2 is negative 2c. Negative 2 times c is negative 2c. Negative 2 minus 2 is indeed negative 4, yes? Now we can go through and multiply these together, yes? I talked about this, I think, a little yesterday. Is there any order or necessary order that I have to do before I can start simplifying? No, because I mean, at any point it's multiplying. We have multiple or parentheses being multiplied together, yes? We can multiply any two things in any order. And the reason I mentioned that, that first set of parentheses, not first set, the first fraction, do we have something already in common on top and bottom? So here we have what? X plus 2 over x plus 2, or c plus 2 over c plus 2, yes? Is there anything that's saying that, well, no, I can't reduce that now. I have to wait till I multiply? Well, no, because anything divided by itself is 1. It's already being divided by itself, yes? So if I wanted to, I could go on and just say, no, that's 1. I don't have to rewrite it down. That's going to simplify to 1. Because really that's going to leave us with what? C to the 4th times c squared minus 2c plus 4 times c minus 2 times c minus 2.
Can't you put C minus 2?
We can put it as c minus 2 squared. Yeah. Either way works. Yeah, because if we write it as c minus 2 squared, we can just reduce that exponent from 2 to 1 when we simplify one of them out. I'll show that here in a second. Because at this point here, c minus 2 and the c minus 2 would cancel. Our c squared minus 2c plus 4 will simplify with our c squared minus 2c plus 4. In terms of parentheses, that simplifies everything out, and the only thing left parentheses-wise is c minus 2. Now our c to the 4th and c to the 3rd would reduce. One of the ways we can look at it is when we divide by bases, we subtract the exponents. So 4 minus 3 is 1. Since it's bigger on top, it will stay on top. And realistically, everything in the denominator has been simplified. No, because you can, and if you did, it would be c squared minus 2c. We'd have to multiply it through. There's no real big difference between c times c minus 2 and c squared minus 2c. And especially if it had been c plus 2 times c minus 2 all over 4 or all over something, there's definitely no reason to multiply the parentheses back out. Questions on this here? Questions on anything we've done so far? Okay. I'm going to skip to the last two. These here realistically aren't any different than what we've been doing. Because we actually have two parentheses or two fractions being multiplied together, we can write them as two fractions. And we can see that with the x plus 2 over x squared or x cubed minus 27, we can see it is actually written as a fraction. Our x squared plus 3x plus 9 does have a denominator. The bottom of the fraction, what is on the bottom of that fraction? 1. Any number is always over 1. We just never write it. Because if I divide something by 1, we just get that number back. So it's always understood that this denominator here is 1. Now the x plus 2 on top of our first fraction, degree is 1, no greatest common factor, nothing we can do with that there. Now the denominator, x cubed minus 27. This looks to be our difference of two cubes. X cubed minus 27 looks like it'd be a difference of two cubes. Well, x cubed, x times itself 3 times is x cubed. That's a perfect cube. We just need to figure out what times itself 3 times is 27. And it indeed would be 3. So the way that we can think of this here is really as x cubed minus 3 cubed are a and b. What times itself 3 times is x cubed, well, that'd be x. What times itself 3 times is 27, that would be 3. So a in this case is x, b is 3. And according to the formula, we have a minus b. So it'd be x minus 3. And in the parentheses, we'd have our a term being squared plus a times b, so x times 3, plus b squared, so that would be 3 squared. And especially if we have a sum or difference of perfect cubes, there's a good chance that that quadratic, the x squared plus 3x plus 9, is going to show up in that sum or difference of two cubes. And once we finish simplifying the denominator here, we get x squared plus 3x plus 9. On top, we do have the x squared plus 3x plus 9 all over 1. Questions on this here? Now we can start, we need to multiply them together, yes? And then we can simplify. Well, when we multiply them together, really what are we doing? We're just joining the tops with the tops, bottoms with the bottoms, yes? I mean, that's one way to do it. Or we can just say x plus 2 times x squared plus 3x plus 9 over x minus 3 times x squared plus 3x plus 9. And the only thing that's going to simplify out is the quadratic part, the x squared plus 3x plus 9, leaving us with x plus 2 over x minus 3. Questions on this here? Now, the only restriction for this here would be 3. Because x minus 3, 3 would make that be 0. 3 minus 3 is 0. That's actually the only restriction. The x squared plus 3x plus 9 does not factor. It's complex solution, so there's actually no value of x that would actually make it be 0. So it does not actually have restrictions. And this is it here. Questions on this here? Do we feel comfortable with these here? For the most part, yeah, that is it. Now, I would highly, highly suggest y'all start working on it. I know we've got some time before the homework is officially due. Start working on it, start practicing. That way, if you do have questions or get stumped on one of them, we can go over it, especially even on Monday. We can start answering those questions and getting those things figured out so you're not waiting till the end